This is section 5.6 on Hess's law. This is really great news. You do not have to do calorimetry to get a delta H of reaction. You can actually do it all on paper, all right? So what you're going to be doing is using equations and delta H of reaction values that are given to you. All right, so let's say we want to find a delta H of reaction for the combustion of methane. You've turned on your stove and the methane gas is burning. So what you would be given are two different reactions, and you would look at them and you'd say, what can I do to these reactions to make them add up to the reaction I desire? Well, as you look at the first one, you see two waters as a gas. As you look at the second one, you see two waters as a gas. When you would add these together, you would get the desired equation. So delta H for the reaction is the sum of the delta H for each step, and in this case, it is a negative 890 kilojoules. It's an exothermic reaction. It's kind of a gift after we've gone through calorimetry. So there are some rules you need to follow, that if the reaction is multiplied by a factor, delta H must also be multiplied by a factor. Same goes with division. If you divide, you need to divide the delta H. If you're going to reverse the equation, the sign of delta H changes. A positive will go to a negative will go to a positive. Finally, leave substances that appear in more than one equation until you're almost done. This is an exceedingly simple reaction. So it shows that all substances not appearing in the desired equation must cancel, and that would be the waters. Here's another example. It says determine the enthalpy change for the reaction of calcium hydroxide with sulfur trioxide to form calcium sulfate and water. Again, you would be given both the equations and the delta H values. What you have to do is look at it and decide what to do. Well, it's another easy one. Away go the calcium oxides, and we have the balanced equation. Adding the two equations gave that required equation, and the enthalpy changes have also been added. Now, do you think you'll have something quite that easy on your exam? I hate to bust your bubble, but it's going to be a little bit more challenging. So let's look at something that you might see on your exam. You might see, determine the delta H for the reaction. This is acetylene reacting with dinitrogen oxide to form CO2, water, and nitrogen. It's not a combustion reaction, but it's just an unusual reaction. Again, you would be given all of this information. You'd be given the equation for acetylene, you'd be given the equation for nitrogen, and your job would be to look at this and try to figure out what to do. So you've got to adjust these equations so they have the proper amounts. If I look at the acetylene in the equation, I notice that there is only one, and here there are two. So I would divide the first equation by 2 to get the right amount of acetylene. I would write C2H2, I'm going to leave the phases off, 5/2 O2 going to form 2CO2 plus 1 water. I would also be dividing 2512 divided by 2, and that would give me a negative 1206 in terms of my kilojoules. Now for the second one, you look and you go, oh, I've got to figure out how to get some dinitrogen oxide as a reactant. When I look at the given equation, I see that it is a product. So you're going to have to reverse that reaction. And notice there is also a 5 as a coefficient, and you're going to have to multiply it by 5. So let's write this one down. 5N2O goes to form 5N2 plus 5/2 O2. I need to change the sign. I need to go to a minus 81.6. and I need to multiply it by 5, and I come up with a minus 406. I've looked at the main species here, and now I have to make sure this will work. Well, I notice the 5/2 O2s go away, and I'm left with exactly what I need. So what I will do is I will mathematically combine those two terms to give a minus 1664. kilojoules. There are plenty of examples for you to do in your homework, and I encourage you to do them because this is really easy. It just takes a little bit of thought process. As usual, please ask questions. Don't leave them unanswered. We'd rather answer them before you sit down to take an exam.